So I'll take one by one the problems. So let me take the first set. This is on Kirchhoff's law first. The problems on Kirchhoff's law. Okay, so the first problem is very easy, but the problem is in a hurry I forgot to give the figure itself. Okay, so I'll just show you the figure now here. Just a minute. So the first problem is, in the given circuit, the current from A to B through the cell E2. I'll just draw the figure. So the figure is this. So these problems are actually based on Kirchhoff's law in the third chapter. So this is suppose E1 cell, and it has EMF 2 volt. Then another cell, there is no resistance across this cell. Then I have the third cell also like this, and there is a resistance like this. And suppose this is E3, has voltage 2 volt. This is E2. This is also having 2 volt. Okay. So the question is, what is the value of the current flowing from A to B? A is this one, and this is B, through this E2 cell. What is the current through E2 cell from A to B? So this is the question. So if you apply Kirchhoff's current and voltage law, you'll be able to find this out. Okay, so I don't know whether I should give you time to quickly solve. Maybe I'll just give you 2 minutes, and another 3 minutes I'll solve the problem. So almost some 12 problems are there in 2 sets. We'll take each 5 minutes to solve. Just see whether, okay, so this, okay, the resistance for this actually is 4 ohm again. This is also 4 ohm. So you have to find out the current through E2, which is flowing from A to B. So this is the question here. So this is from the first problem set based on Kirchhoff's law. This is actually very easy. If I give you clue, you can find it out. Suppose I think that there is a current flowing I1 from this E3. Okay. Similarly, from E1, suppose I take this as E2, and this is, sorry, I1. This is I1. Okay. So I1 is flowing from the battery E1, and from the battery or the cell E2, I2 is flowing. So you look here. So upon coming here, according to Kirchhoff's current law, the same current has to go through this way, okay, from the junction. So here I suppose this is I1 plus I2 flowing from A to B. Now if you apply Kirchhoff's law, okay, this way and this way, there are 2 loops, suppose. So this is loop 1 and this is loop 2, okay, L2. If I apply the Kirchhoff's law, Kirchhoff's KVL actually, KVL for L1, KVL for loop 1. So what you get is, this is I1, so 4I1, see, 4I1 is the current. So I'm coming from actually cell to this way, and see there is no resistance across this line A to B, so there is no drop across this. So only voltage drop will be across this 4 ohm. So this is equal to, see, I have 2 cells in this loop. I have to check whether some cell is positive or some cell is negative. I'll repeat how we can find out. If the current is flowing out from the positive terminal of the cell, then it has to be positive. Okay. If this is negative, so current is flowing out from negative electrode, then you have to take EMF as negative. Okay. So here look in this. So E1 is actually we have to take positive, and look here for E2 you have to take negative. So here 2 volt minus 2 volt. So you get actually 0. So what you get, current I1 is 0. Similarly, if you apply to this L2 also KVL for L2, look 2 also, what you get is actually 4I2 is equal to 0. Okay, you'll see that it will be 0. So both I1 and I2 are 0. That means no current is flowing through AB. So if I1 is 0, I2 also 0. So I1 plus I2 also will be 0. So there were options given in the question. The first option in the question will be the answer. Okay. So the first option, that is 0. I'll show you the question again. Okay, maybe I'll show you the question first, then I'll go to the presentation and solve. So this was the question. Okay, so see this is the option, first option, which is the answer, correct answer for this. Okay, so the second question is 12 wires of same length and each of resistance small r are connected to form a frame of a cube. Actually, this type of problem is already solved in your example. If you see in the book, in the example already solved. Okay, then I'll not solve this problem. Second problem, if people should try. In fact, what I can do is I can tell you the answer. So this is the answer actually, 5 by 6 into r. This will be the answer for this question. If people can note down, who are there in the WhatsApp group. If you are not there in WhatsApp group, if people can join in our WhatsApp group, so where I have uploaded the problem sheet. So C will be the answer for this. Actually, this question is very straightforward and it is already solved in your example book, like example in the NCERT textbook. You try to solve by yourself. Okay, if there is still some problem, I will take up in the next class. Okay, so this question also Q3. This question is also very straightforward. Okay, so I'll just take this question still for discussion. So these are actually based on Kirchhoff's law, and these questions are some of the questions which I have picked up from your old question paper, CBSE board, and some of them I have obtained from NEET or AIMS or JEE main exam paper. Okay, so this question is actually very straightforward. See, the question is saying that find the potential difference across each cell. You have to find out potential difference across each cell. Okay, what is the potential difference across each cell? And the second part of this question is actually what is the energy dissipation in R? R means capital R. What is the energy dissipation through this capital R? That means 4 ohm. So how to find out what is the potential difference across each cell? You can just simply see that here, if you just think this is actually internal resistance for this cell, and R2, small R2 also internal resistance for this cell. So here, this is actually the external resistance, capital R. So when I connect an external resistance capital R, okay, capital R, like this with any cell. What is the potential difference across this cell? It will be the terminal potential, okay, it will be the terminal potential. So if you know the current through this circuit, then what you will get the terminal potential as minus this, okay. So obviously there will be some internal resistance small r. So this will be actually your potential difference across the cell when there is a resistance external appliances connected across the cell. So in this case, you cannot like straightforward use Ohm's law or something. So in this case, since there are two cells and there are resistances like internal resistances also, so what you can do is you just apply Kirchhoff's current law and voltage law simply, and then see whether you can find out the answers for this. So look, if you think that this one is giving E1 current and this E2 is giving it I2 current. So according to Kirchhoff's current law, this will be I1 plus I2, okay, which is flowing through this. And upon coming over here at this junction, suppose this is A and this is B. So upon coming to B, this I1 plus I2 current will be divided into two parts again. So this will be I1, and in this way it will be I2. This is Kirchhoff's current law. Now you take any loop. Suppose you take the loop like this. So this is suppose L1, and if I take this is L2 suppose. Same thing now I have to do. So I'll just give you 2 minutes to write an, or maybe you people can, some of you can uh, unmute yourself and tell me what will be the Kirchhoff's KVL for loop 1. Nikhil, Priyadarshini, you people can speak to me. Okay, so KVL, I just want to write KVL for loop 1. Anyone can volunteer. Anyone can volunteer for this. Okay. Okay. If anyone is coming forward, I'll be happy. Otherwise, I'm writing. You just see whether you are thinking the same thing. Okay. So for loop L1, see I have resistance this 2 ohm through which the I1 is flowing. Okay. The current direction is this way. So I can write 2 into I1. Okay. Another resistance is 4 ohm through which it is, what is the voltage drop across this 4? This is 4 into I1 plus I2. Okay. And then, so this is equal to, see, I have to see what is the cell. See, this is the cell and current is flowing out from the positive terminal. So I can write simply 12. So if I just simplify a little bit, so what I get this, so this 6, this one, and 4 I2, okay, is equal to 12. Further, upon further simplification, what I can write is 3 I1 plus 2 I2 is equal to 6. Okay, this is for loop 1. Okay, and I can write for loop 2. Okay, for loop L2. Okay, so see, in this case, this is I2. This is the current flowing through this I2 into 1 ohm. So this is I2 plus, so through this again, so 4 I1 plus 4 I2. Okay, so this is the current flowing through this. So I'm going from this way. Okay, so along with the current direction of I2. So yeah, maybe, so cell to A to B, B to cell again, like that. Okay, so and now here also this is 6. I'm taking positive because I have taken the current flowing out from positive terminal. So this will give you 5I1, sorry, 4I1 plus 5I2. is equal to 6. So these two equations you have to solve. Okay, you have to solve these two equations. If you just uh, use the elimination process or something, see, I'll tell you, I am not going to solve rigorously here. So you get these two equations, and then once you solve this equation, what you get is I1 is equal to minus 6 by 7 ampere. Okay, and I2, yeah. So what will be the I2? I2 will be actually 18 by 7. Okay, if you add these two, so total current which is flowing through R, I'm writing R. So this will be actually 12 by 7. Okay, 12 by 7 ampere. Okay, so these are the currents. Now look, as I told, so if you find out that if you have to find out the terminal potential, so you have got the current now, current through R. So what is the potential difference across each cell? So that will be the terminal potential. That means the potential drop across R, capital R, or 4 ohm. So that will give you the simply that will give you the potential across each cell, potential difference across each cell, across each cell. Okay, so this will be actually, so potential difference across each cell will be something like this one, 48 by 7. Okay, you have to multiply this, see IR, see you have to multiply 4 over here, so then you will get that. Okay, so you get this much volt. Okay, 48 by 7 volt. Now what is the energy dissipation across 4 ohm? So this is the current I have got. So I can write I square R, I square into R. This will be the energy dissipation across 4 ohm. Okay, so this will be 12 by 7 whole square into 4. So this will be so whatever you get, so that is the answer. So I'll just tell you what it is. So it will be something like this. Energy means joule. Okay, so this will be in joule. Okay, so I hope you guys have understood this. So this was very straightforward problem. Okay, only thing you have to understand, how do you calculate the potential difference across each cell. That is the terminal potential of the battery, which you will get, see, from the voltage drop across the external resistance. So that you have to understand. Okay, so we will go to the next problem. So the next problem is from the first. So from this itself, so this problem is actually very straightforward. You look this fourth one. So you have to find out the reading of the current in this circuit. Okay. So this is very straightforward. So how do you calculate this? See, look here. So these two are actually parallel. Okay. And again, this also is parallel to this. Okay. So this 2, 2, 2. So you will get actually 2 by 3. Okay, 2 by 3, and along with that this is in series. So if you just solve this, like you have to find out the equivalent resistance. Okay, equivalent resistance for all of this. So see, these two and these two, this all, so 1 by 2 plus 1 by 2 plus 1 by 2 will be 1 by R equivalent. Along with that, this is the series. So if you solve that, you will get the answer B. Okay, 3 by 4 will be 3 by 4 ampere will be the reading in this ampere ammeter. Okay, this was very straightforward and very simple problem. So these two problems are a little bit tricky. Let us see how we can solve. So the question, you might be able to see that in the given circuit, what is the potential drop across the capacitor. See, in this circuit there are three batteries actually. See, this is having voltage V, this is also having voltage V, this is having voltage 2V, and see in the middle branch, you see in the middle branch there is a capacitor. Okay, there is a capacitor, and look, this is actually a DC circuit. Okay, this is a DC circuit. DC means what? uh, Current is actually fixed. Okay, it has a current or voltage, it has a fixed value. So you have to find out what is the voltage drop across C. So if you will have any idea, you can tell me, or otherwise I'll straightforward go to solve it. Okay, uh, look here, since this is a DC circuit, what is the property of capacitor? Actually, we learned that, but I don't know whether you have already learned that somewhat. I think in the second chapter I had little bit told about this capacitor. So capacitor, when it is actually connected to a DC battery, what happens to this? What happens to, suppose this has voltage 10 volt. Okay, suppose capacitor is C. Okay, you can take any so maybe some 10 microcoulomb mu C. Okay, sorry, microfarad. So what will be the situation? Okay, what will be the situation? This is a charging circuit. Okay, so when you put your mobile or anything electronic gadgets in charging, what happens? You just connect with a like plug. So actually there is a, you will be seeing that there will be an adapter. So that is actually a DC, like it is a converter. So from AC to DC it converts, and then the capacitor which is there in the battery will be getting charged. Okay, and then the charge will be actually charge will be held in this capacitor for your future use. So that is the thing. So what happens, like when this voltage, this battery flows a current through this. So in fact, what will happen? The positive charges will be actually accumulated here, and negative charges will be starting piling up in the other plate, okay, of the capacitor. And current, it will see, this capacitor will be charged until it is getting fully charged. And see, when it is getting fully charged, what will be the current through the circuit? What will be the current through the circuit? When the capacitor gets fully charged, the current in the circuit will be zero. What is the current in the circuit? It will be zero, because what happens upon fully upon getting fully charged, the potential difference across these two plates will be same as your source. So here also the potential difference will be 10 volt across this. Okay, for this uh, these two plates of the capacitor. So when that happens, so there is no potential difference between A, B point. Suppose this is B point and C point. Okay, there is no potential difference between these 2 points, so there is no flow of charge. See, potential, when there is a potential difference. Okay, so when there is a potential, suppose this is high potential. Okay, and this is low potential. Suppose this is 0 and this is having some value 5 volt. If there is a potential difference, then charge will flow. Okay, charge will flow to this. Okay, so suppose electrons are flowing, or electrons are flowing for a conductor, so electrons will flow. Actually, the direction of the flow of electron will be opposite, in the sense electrons will be going from negative, like lower potential to, if these are negative particles, they will go to positive. Okay, so the current will flow in the opposite direction. So this is how, when there is a potential difference, there will be current flowing through that. In the DC circuit, if you wait for some time, okay, so this capacitor will be fully charged, and the potential drop. Okay, so after some time, it will not allow any current through it. Okay, so current will be zero through this. So what we have to see, obviously we have to use the Kirchhoff's law. Okay, we have to use Kirchhoff KVL or KCL also. See, I'll see whenever there is a capacitor in a DC circuit, you have to think that after some time there will be in the steady state. In the steady state, no current is flowing. Current is flowing through the branch having capacitor, having a capacitor, having a capacitor. Okay, so if this is the thing, then what I can see, I just take like, see, suppose I current is coming out from this battery. Okay, so there is no branching over here. So if there is no branching, the same current will go up to here. Okay, so the same current will flow throughout the circuit. So throughout the circuit, same current will flow. Now I'll do, I'll just write the Kirchhoff law for this. So look what I can write. See the voltage drop. So the 2R into I for this. Okay, in the same direction, current is flowing for this also. So this is again I into R. Okay, I'm writing KVL for the whole loop. Okay, since current is not flowing in the middle, so I'm going at the periphery or the outer branch itself, outer loop itself. And see, I have to write the summation over the EMF of the battery. So in this case, you have to look whether these two are like EMFs are positive or negative. So in this case, look, the current is coming out from the negative terminal, and for this case, it is coming out from positive terminal. So this I have to take positive 2, and here 2 volt, so 2V, and this is minus V. So what I get is actually 3I into R is equal to V. So from here, if I find out I, what is that? V by 3R. Okay. So once I get this current, so now it is easy. So my question was, actually our aim is to find out the potential drop across this capacitor. Okay. So suppose the potential drop across this is VC. Okay. Across this is VC. And already we know this is V. See, since this end and this end, they are actually at the same like terminals. So the potential drop across this branch will be equal to the potential drop across this branch as well, and same as this also. Okay, because these are end points and these are all parallel points, actually parallel branches. So what I can write is, see the potential in the middle branch, V. So potential drop across this middle branch is V plus VC. That is equal to, see, I'll take this one, V plus I into R. So this will be the equation. So see, I know the current R. So this V can be cancelled. So V C is equal to I into R. Okay, I into R. So what is I? I is already given, V by 3R into this is R. Okay, so you will get the potential drop across the capacitor is V by 3. Okay, this is V by 3. So there, see, if you see the question paper, question said here, options are, various options are given. So among this, see, this option C will be the answer. Okay, so option C will be the answer, V by 3. So this was actually asked in some competitive exam. I guess it was JEE main, some year, I don't remember the year. And this is also an important problem. Look, this sixth problem. So this problem is saying that in the circuit, so in this circuit shown below, each of 5 volt, so each of this cell, actually each of this cell has EMF 5 volt and has internal resistance 2.2 ohm. So for each of them, okay, I'll just, and then you have to find out the reading of this voltmeter. This is a voltmeter. You have to find out the reading of the voltmeter. That means what is the voltage across this cell, okay, this cell. That is the voltmeter reading. So we have to find out that. Okay, let us okay, let me just copy this figure. I'll just repeat the question for you. See here, there are 3, 3, 6, and 8. 8 cells are there. So each of them actually have EMF 5 volt and internal resistance 0.2 ohm. So what you have to find out, that is the voltage reading of this voltmeter. This is a voltmeter. Okay. So you have to find out the reading of the voltmeter. So this is the question. This is actually from the combination of the cells. Okay. This is not exactly Kirchhoff's law, but this is from combination of the cells. You, I don't know whether you people can understand. See, so when I have this kind of combination, like negative terminal of one battery is connected to the positive terminal of the other battery and going like that, then it is a series combination. You look what is happening over here in this circuit. In this circuit, what is happening? In each case, look, this is the positive terminal connected to negative terminal of the other battery. This is the positive terminal connected to the negative terminal of the other one. So like that, if you look throughout this, okay, starting from here to the complete loop, you look that all of them are actually in series. All of them are in series. So if I somehow uh, can find out the current, okay, so I have EMF 5 volts and internal resistance 0.2 ohm. So now look, I am just going to find out what is the current in this. So in a series, you will get current. Actually, what is the current means? Total EMF, okay, total EMF divided by total resistance in the circuit, right? Here internal resistance, total internal resistance, total internal resistance of in the circuit. So look here, actually if you have gone through our previous classes, or if you have uh, already read this part, combination of cells, actually if the cells are in series, so you will get E1 plus E2 plus E3, like that, equivalent EMF of the equivalent cell. So if you have equal and n number of cells, so you will get total EMF n into E. So here I have 3, 3, 6, and 8. So this is 8, and here again the resistance, internal resistance in a series circuit will be always additive, okay, or I can say series combination of the internal resistances. So you will get here, since the internal resistances are also equal in amount, so you will get n into R. So this n goes off. So what you get is, yeah, I think Kirtana has uh, got the point. So you have 5 divided by 0.2. So the current will be 25 ampere. Okay. Okay. Once I get this, I have to find out what is uh, the voltage across this. So when if I am just connecting this voltmeter to find out the voltage, what I have to do? I have to find out the voltage across this. Okay, across this. So how to find out this? So this is a cell. Now you just forget about this part. Okay, for the time being. Okay, because each cell has their own potential difference. Okay, these are in series. So across each cell there will be potential difference, and that is different. That may be different. For this case, actually it will be maybe the same. Okay, it will be the same actually for this case, because each cell are having same EMF, same internal resistances. So I have got current. See, whenever I I have a cell, I know EMF, I know internal resistance, I have suppose voltmeter over here. Okay, so if you want to calculate, so this is external circuit. Okay, so this is voltmeter. So if you want to calculate the potential difference across, or potential difference or the voltage in this voltmeter, so what is the formula? As I told, this will be the terminal potential, that is V is equal to E minus I into internal resistance. So I have got already this. E I know 5, so I is 25 and this is 0.2. Okay, so what you get is 0. So what is the potential, uh, like what is the reading in this voltmeter? V is equal to 0. Okay, so this is the question. This is actually like, yeah, Kirtana, you are right. Kirtana has written in the chat box. Okay, you are correct, Kirtana. Okay, so with this we have finished this uh, problem set. We'll go to the next problem set. So I'll not take up all the questions over there. I'll tell you the answers for all of them, but I'll solve like the tricky ones. Okay, I'll solve the tricky ones. Okay. So here also there are 6 problems. I hope I'll be able to finish this in time. Maybe I may go up to 10 to 15. Okay, say 17 or 7:15. I'll take up the tricky problem here. See here, the first question is this one. In the circuit, in this circuit, what is the current? So there are 3 options here. Actually, this okay. I'll just redraw the figure itself, because uh, I'm sorry. Actually, in a hurry, I had drawn this figure a little wrong. I hope you people will be able to solve this problem. See, there is another wire connecting A and B. So if I give that, that is the question actually. Okay. So this is the question. Okay, that means here, see, so this is kind of a like Houston bridge, where this is actually simply a wire. This is 3 ohm resistance. Okay, this is also simply a conducting wire, and this, instead of a galvanometer, simply this B and D points are connected by a wire. So you have to find out what is the, actually there are 4 options in this question. I'll just tell you what are the options, and in fact you have to answer which, like there may be multiple answer also. So what is the correct option for that? Okay, the first option is, what is the current flowing through the circuit? What is the current flowing through the circuit? So that question, that option is there. So I hope you people will be able to solve this problem, but I'll just discuss because time is less. If people are not answering the WhatsApp group, so I hope you people can solve this problem and answer me maybe sometime in the WhatsApp group. So look here. So whenever I have, see, I have 2 paths. Okay, 2 paths like this, and I have a battery connected to this. Okay, and I have, suppose current is flowing through this I, and it will be broken into 2 parts. Suppose I1 and I2. Okay, these 2 parts, it will be again, it will be I over here, I1 plus I2. Upon coming over here, they will be added up to each other. Okay, so look now, this I1 and I2, the value of I1 and I2, which one is greater and which one is lesser, or whether they are equal or whatever. So if you want to know that, you have to know what is the resistance. Suppose this is R1 and this is R2. So suppose your resistance R1 is much greater than, or maybe greater than R2, then this current, see, I1 will be less, because current will always prefer to go through the less resistive path. So I1 will be less than I2. Okay, so current will prefer to go through the less resistive path. Look here, so the current, whatever current may be, I don't know what is the current. Now, you see, if you want to calculate the equivalent resistance for the circuit and then find out the current, that may not give you the correct answer for this. Okay, so what you have to see, you have to see through which path the current is flowing in this circuit. Look here, between A and D there is 2 ohm resistance, and between A and B there is no resistance. That means this is zero resistive path. The whole current will try to pass through this, and this way current will be zero, because this is zero resistive path. So there is no division of the current. The whole current will pass through this AB path. Similarly, there is 3 ohm resistance over here, and now there B and D are connected by a conducting wire. So the whole current will go, see, A to B, B to D, and D to C. So A to B, then B to D, and D to C. This way it will flow. So this will go like this, okay, coming this way, and then go in this way, and like that. So what I can tell you, that from here current is flowing only through this 1 ohm resistance. So what will be the current in the circuit? V by R. R is 1 ohm. So current in the circuit will be 6. Okay, 6 ampere. Yes, Kirtana, you are right. So the second option is, what is the current flowing uh, through the branch BD? Is that 0? No, it is actually 6 ampere. Actually, there is option whether this current will be 0. No, that is not 0. Through BD, it is not 0. Okay, so there will be another. See, what is the power? Then what is the power dissipated in this circuit? Okay, resistors. So there are resistors, right? What is the power dissipation through this? Power dissipation through this. So power dissipation through 2 ohm and 3 ohm will be 0, because current is not flowing through that. And what will be the power dissipation through this 1 ohm? Power dissipation will be actually I square R. So I square R is actually 1 ohm. So this will, I is 6. So it will be 30 watt. Okay. So this 36 watt. So this is the power dissipation also will be only through R, see, 1 ohm. Okay. So this was very simple question, but still I thought to discuss with you people. Okay. Now I'll go to the next question. So this next question is, actually I just draw the yeah. Suppose there are two bulbs. Okay, they are connected in a series like this with a battery having voltage V. And see, for the bulb 1, this is 1 suppose, and this is bulb 2. For the bulb 1, the power rating is written like this: P1 watt, and V volt, like that it is written. Okay, and for this P2 watt and V volt, these are the power ratings written in this. So now if these two are connected in a series like this, so what is the question is, what is the total power now in this? What is the total power? Total power, actually you can say total power dissipation or power rating, maybe total power. What is the total power dissipation? So this is the question. So for power dissipation, you have to write I square R. Okay. So this is the power dissipation formula, right? So what you have to find out then? Power dissipation, you can even write in other way also, obviously. So I square R. So you can just convert I as V also, doesn't matter. Or maybe if you replace the R also, then it's fine. But in this case, how to solve this problem? So there are power ratings given for both the bulbs, okay, and they are connected in the series with the battery having voltage V. So what will be the power dissipation now? Total power dissipation. Okay, so this problem, see how you can solve. Better to find out the equivalent resistance for the circuit and find out the current also. So that is the simplest way to do this problem, solve this problem. Let us see the power rating, what we can get from power rating. So if you are given a power rating like this P1 watt and V volt, that means what? So see from here actually we can find out the current as well as I can find out. So P is equal to V into I. Okay. So or we can, so from here we can find out the current limit as well as I can find out from this formula I square R, I can find out the R also from here. So I square R also P, okay, or VI, P is equal to VI. So these are two formula. From this formula, if the power rating is given like this, so you know the voltage is V. So sometime it will be written 240 volt and 100 watt. Kind of that it will be given. So this is power and this is the voltage limit. Okay, across which you can connect the bulb. That means this much is the voltage across the bulb. This much, so this is maybe 240 here. It is V, and this is the watt. This is the wattage. That means the power it can dissipate. It can dissipate. So from here, if I know the P, so P is equal to V into I. So from here I can find out the limit of the current in this. Okay, how much current, maximum current it can withstand. Or if I know power and voltage from here also, I can find out what is the resistance. So using this formula, so I see R I can find out P by I square like this. Okay, and I square I can replace from here again. Okay, I square I don't know, so I know only V and P. So I can, so this, suppose this is P1, I'll write what is the resistance R1. So this is P1 divided by, see, this I is actually P by V, so V square will go up and this is P1 square here. Okay, from using these two formula. Okay, using these two formula I am trying to find out the resistance for the bulbs. So you'll get, see, you'll get actually, so what you get is, I'll just erase this part. Okay, so you get R1 is equal to V square by P1. Similarly, if I do for the second one, so what I'll get, second bulb R2 I'll get V square by, because both rating, voltage rating is same, so P2, yes, this I'll get. Now see, I see these are in series, so I get R equivalent for this is actually uh, V square if you take common, so 1 by P1 plus 1 by P2. Okay, so from here I can get V square P1 plus P2 divided by
P1, P2.
P1 P2. Yes, right. So I got see I got R equivalent. Okay, now I can find out. See, I got equivalent resistance for the circuit. I know the voltage for this. What is the current in the circuit? So V by R equivalent. Okay. So if I just uh, see, I have got R equivalent. So now, if you want to find out the power dissipation now, so I square, so which I'll get from here, and I have got R equivalent for the circuit. So if you just multiply these two, then you'll get the answer. So what is the answer for this? Then the answer will be yes, P1 P2 divided by P1 plus P2. Okay, this is the answer. Are you getting the same thing, Kirtana?
Yes, sir. Yes, I'm doing. Yes, sir.
Okay.
I know.
Okay, good. Okay, so this is how you can solve this kind of problem. Then I have, okay, so I'll just pick up the most tricky problem now here. So, okay, so most tricky, actually these are not very tricky also, but look, this problem, these two problems, basically you can, I think I have another one also. Okay, so I'll just now, so this is a very straightforward problem from meter bridge. I'm not going to solve this. In fact, I'm just telling you the answer. So this answer will be this one. You try to solve it and write me in WhatsApp group whether you are getting this or not. Otherwise, I'll send you the solution over there. I may not be able to solve all in the class. So I'll just take up this problem. So this is also very simple problem. This, see, whenever you have been given, see, this question is the equivalent resistance between point A and B. See, between A and B, this point, you have to find out what is the equivalent resistance. So to solve this kind of problem, so what you'll do, there is no battery also connected over here, so you will not be able to find out what is current and all. Okay, so how to find out this? Okay, look, whenever there is a Houston bridge given, what will be your first job? Your first job will be to see whether the bridge is at the balance condition or not. Okay, balance condition, how to check the balance condition? You know, right? What is the null condition for a or balance condition? Balance condition for a Houston bridge. Okay, see, I'll tell you here. The balance condition, you know, like, see, R1 by R2 is equal to R2 by R3. Okay, the resistance in the four arms, R3 by R4. Okay, so if you just write, so this is A, B, then C, and this is D. So you know now, like, between A, B, what is the arm? This is the second arm. Between A, D, arm is R1, this is R4, and this is R3. Okay, so these are the arms, right? So you take the ratio and see whether, see, R1 by R2 is equal to see, R1 by R2. What is R1 by R2? So R1 by R2 is 4 by 2. So this is actually 2. What about R3 by R4? R3 by R4 also you can see this will be 2. So if this is satisfied, this is satisfied now. R1 by R2 is equal to R3 by R4. That means the bridge is at balance condition. At balance condition. So at the balance condition of the bridge, no current is flowing through this resistance. Okay, no current is flowing through this resistance. That means, look, between A and B, see, this is a path for current and another path is this one. So you have parallel combination of this. So this is actually series, 2 and 2, they are series. So you will get, actually you'll get like this equivalent circuit like this. Okay, like this. So these are then A and B. You get like this now at the balance condition. This is 2 ohm. Okay, this is 2 ohm, and this is 4 ohm, and this is also 4 ohm. So like this you get. So this is actually 4. So 4 into the parallel combination of that. So 4 into 8 divided by 12. So you will get actually, so this is 8 by 3. Okay, 8 by 3 ohm. So this is actually a problem which you may get in your board exam or maybe any competitive exam also. This seems to be very simple, but at that time you may not be able to find out whether this is a balanced condition or what is the way I should take like follow to follow, like get the equivalent resistance for this. So you have to always, whenever there is a breeze is given, whenever there is a Houston breeze given, you have to remember that you have to see whether there is a like this bridge is at balance condition or not. If this is in balance condition, then no current is flowing from this point to this point. Okay, in the middle branch there will be no current. Okay, so that is what is the fundamental knowledge you should be remembering here. Okay, I think, yeah, so that is the answer for this. Then we'll go to the, so this question I'm not going to solve. I'll just take up the sixth problem. So this problem also is very straightforward. The problem will read, so this problem in the figure below, a long uniform potentiometer wire AB. So this AB is the long wire having a constant potential gradient along its length. The null points for the two primary cells E1 and E2 connected like this. Okay, so for null point for this condition is given as 120 centimeter, and for other combination of these two cells, the null point is actually at 300 centimeter. So what you have to find out from here, what is the ratio of E1 to E2, and what is the null position. That means if you take, instead of taking both the cells, if you take only one cell, that is E1, where you might get the null point. So that is the wire, means at which length of the wire you get the null point. So this is the question. So let us try to solve it. So with that we'll be finishing this chapter, and on Sunday we'll be starting with our new chapter, that is the fourth chapter. So there will be learning the magnetic effect of the current and all, moving charges and current, moving charges and magnetism. So here, look here, this is a potentiometer. So you have been given two cells, E1 and E2, and see there are two different combinations in two cases. So in this case and this case, look, okay, they are in series, but they are, see, some case, one case, both the negative terminals are added to each other, like connected to each other, and in this case, negative then positive. Okay, negative and positive are connected to each other. Okay, so in these two conditions, you are getting the null condition at different length of the wire, potentiometer wire. So once you get for this condition, let us write the Kirchhoff's law for first case. So suppose this case I am writing. So if I go in this way, okay, the loop through the loop, let us see what we get. See, I'll get, see, let us see the potential gradient. Let us take potential gradient at phi. So that is actually E by, so that is the potential E by length of the wire. Okay, so if I want to find out the EMF of the wire of this much length, I have to multiply this. So look, 120 into pi, that is the potential drop across this length, and that will be equal to, see, according to Kirchhoff's law, that will be equal to the EMF of this. Okay, so combination of this. So in this case, we look, is if I take this as positive because current is flowing out from here, and say current is flowing out from the second cell from the negative terminal, so I'll get E1 minus E2. So this is equation 1. And similarly, I'll take for the other case also the loop. See, this loop, for this loop, So the potential drop across the wire is actually 300 into 5. And look here, so current is flowing out from this cell also from positive terminal, from here also positive terminal. It will be U1 plus E2. So these are two equations. If I solve these two equations, then it is easy to get the things. Okay, so if I just add them up, so what we'll get if we add them up? So we'll get 2U1 is equal to 4, I think 425. Okay, so from here I can get a relation between U1 and this potential gradient phi. So this is 210 into 5. Okay, so this will give you the second answer. If I would have taken only the first cell, so this is the length. See, potential gradient into length will be the EMF. Okay, so the EMF, so that means, so if you only take this cell, only the cell 1, then where you would get the null condition at 210 centimeter, that means 210 centimeter. This will be the length of the wire, potentiometer wire, where you would get the null condition if you use only the cell 1. Okay, okay, so this answered my second part of the question. Now we'll just check up what is the ratio of E1 by E2. Okay, if you want to do that, so let us take the ratio of these two. So what I get, the ratio, this is E2 minus E1 minus E2 plus E1 plus E2, that is equal to 120 divided by 300, right? So just, so 6265, so 2 by 5, all right. So just multiply this 5E1 minus 5E2 is equal to 2E1 plus 2E2. So if you just simplify, what you get is 3E1 is equal to 7E2. Okay, so what is the ratio? You look from here, from this, where, so I can get the ratio E1 by E2 as 7 by 3. So this will be your ratio. Okay, E1 by E2. So this was the question from some old CBSE, okay, CBSE paper. Okay, okay, so okay, so these were actually the old paper questions. So I think this will give you a certain idea, okay, how to solve the problems from this chapter. Okay, so with this we'll stop this class for today, and next class will be on Sunday, which uh, where we'll be learning magnetic effect of current. Okay, so yeah, I think most of the people have left because I think it is late. Okay, so guys, we'll meet again on Sunday with a new chapter. Fourth chapter will be learning there. Okay, okay then, bye.